as you all know, is a massively exciting and expanding field. But there's one sort of elephant in the room that keeps coming back to bite us, and that is security. More importantly, the security of your data. Because for most organizations, the data that you have is the most prized asset you actually own. And you're rightly concerned, I guess, about what happens to that data behind the APIs, behind things like Amazon Bedrock. How safe is it? How secure is it? So last year, when I was here, we talked about the service security as a whole. But this year, we're going to talk just about agents themselves and what happens to your data behind the scenes with Amazon Bedrock agents. And hopefully, we can show you how secure it actually is behind the scenes. So my name is Andrew Kane, and we're a global lead for GenAI security and compliance. And hopefully today, I'll shine a light on what happens behind the APIs.
All right, thank you, Andrew, for that. My name is Onopemi Oshinyomi, generally go by Okwe for short. I am a solutions architect with Amazon Web Services. And today, we will be touching on the many aspects of Amazon Bedrock agents security. And it is our expectation that by the end of today's session, you'd leave here fully confident that our agents system is safe and secure and is able to meet and exceed your Gen AI security requirements and needs. These are the areas that we will cover today. We will first of all start with a brief introduction into what the Amazon Bedrock service is. And then we'll touch on the data privacy and protection mechanisms that are available within the Amazon Bedrock service and Amazon Bedrock agents. A significant portion of today's session will focus on Amazon Bedrock agents and the security mechanisms that we have within Amazon Bedrock agents. And my colleague will touch on the data flows for cross-region inferencing and Amazon Bedrock guardrails over the course of this session. So let's start with a high-level introduction of what the Amazon Bedrock service is. Amazon Bedrock is a fully managed generative AI service that makes it easy for customers to build and scale generative AI applications. Now, with Amazon Bedrock, customers are able to easily take advantage of the wealth of foundation models from leading model providers within the application without having to worry about things like model building, model training, or even having to worry about managing the underlying infrastructure upon which the models that they leverage within their application, sits on. Now, in addition to that, you're able to customize the models that you leverage within Amazon Bedrock to adapt it to your own use case or to adapt it for use within the industry domain within which you operate as a customer. With Amazon Bedrock, you're also able to implement retrieval augmented generation workflows, leveraging enterprise data systems that you have within your organization. And further to that, you're able to build agents within Amazon Bedrock that are able to reason and execute multi-step actions based upon the instructions and the prompts that you provide to the agents that you build. And all of what I have mentioned just now, you're able to do in a manner that is safe, that is secure, and that is private, which is of key importance to most customers. Now, Amazon Bedrock is a fully featured service, and so basically, these are the things that we will not touch on today. We're showing you this just so you know what is available within Bedrock, but these are the things we will not touch on today. We will not touch on the wealth of foundation models from leading providers that are available for you to leverage within Amazon Bedrock. Providers like Amazon itself, DeepSeek, AI21 Labs, and also Anthropic. Today also, we will not touch on the possibility of you being able to fine-tune models within Amazon Bedrock, leveraging few labeled data to adapt models to specific use cases that you might have. We also will not talk on continued pre-training, which is basically the case where you leverage a significant amount of unlabeled data to adapt a model for use within the industry domain that you operate in as a customer. And also, we will not touch on the ability of you being able to train a model and then import that model into Amazon Bedrock and then leverage the wealth of functionalities and features that you have within Amazon Bedrock in the use of the model that you import into Bedrock. We also will not talk about prompt caching. We won't talk about knowledge bases, which we largely use to drive RAG workflows. And also, we will not dive deep into guardrails, but my colleague during the course of this session will provide you with insight into what happens behind the APIs and the data flows when you do leverage guardrails within Amazon Bedrock. But what we will do today is we will provide deep insight into the security of your data when handled by Amazon Bedrock agents, when you do build agents within Amazon Bedrock. Now, data is of critical importance to virtually every customer, and typically is the lifeblood of every organization. Now, for customers who leverage generative AI technologies, it's of critical importance to them that the data that they input into these Gen AI technologies are safe, they are private, and they are handled securely. Now, what I want to do now is to provide you insight into some of the mechanisms that we leverage to ensure that data that you leverage for Amazon Bedrock agents are safe and are handled securely. First of all, your data is never shared with foundation model providers. So, for example, when you make a decision to leverage one of the foundation models available within Amazon Bedrock, that model is always deployed within an account that is controlled and managed by Amazon, and data that you share with that model is never shared with the model provider of choice that you leverage within Amazon Bedrock. Secondly, the prompts that you provide to those models and the responses, the inference responses that are generated, are never stored within Amazon Bedrock. And lastly, all of the API calls that you make to the Bedrock APIs remain within the region, with the exception being when you enable cross-region inferencing, and the data flows with regards to that. My colleague also over the course of this session will provide you insight into that. Secondly, we ensure the security of your data by ensuring that your data is always encrypted, whether it's in transit or whether it's stored at rest. For data in transit, we encrypt that with TLS, a minimum of TLS 1.2, although based upon security best practices, we recommend that you leverage TLS 1.3 for the highest level of security. And for data at rest, that is always encrypted with KMS, customer managed keys that you own and that you manage, and that leverage AES 256 encryption keys. And for all of your usage of Amazon Bedrock agents, you are able to track your usage and all of the API calls and activities with common services that I want to believe that you're all familiar with: Amazon CloudWatch and Amazon CloudTrail, with all of those logs being stored in your own account. And as you use Amazon Bedrock agents, you can be fully confident that the service is compliant with the likes of HIPAA, SOC, PCI, FedRAMP, and the likes, to ensure that you remain in compliance based upon the industry that you operate in. Now, this is a typical high-level architecture of what the Amazon Bedrock API typically looks like, and I want to take you through what the access flow looks like for Amazon Bedrock. On the extreme left, you see the customer's account, all right, and the customer's VPC, wherein the customer's application is deployed. And for connectivity to Amazon Bedrock, you have VPC endpoints powered by private link, through which you're able to privately and securely connect your application to the API endpoints of Amazon Bedrock. One thing I, however, want to mention is you are able to actually leverage the internet, leveraging our internet gateway service to actually provide this connectivity. But based upon security best practices, we recommend that you leverage VPC endpoints powered by private link to actually do that. Now, to secure that endpoint and secure the communication between your application and the Bedrock API endpoints, you leverage two things. One, you leverage security groups, which filter the inbound and outbound traffic that can actually traverse the VPC endpoints that you use. And then to drive zero trust principles, you're also able to attach IAM policies that determine what principals are able to call the Bedrock APIs of the Bedrock models that you have deployed for use within your application. Now, for Bedrock, we have two planes, basically for least privileged purposes. You have the control plane, which controls things like model building, model listing, and model customization. And then we also have the API endpoint for the data plane, responsible for runtime activities like inferences and things of that nature. Now, for connectivity between the API endpoints, whether that's the control plane API or the data plane API, we also leverage private link VPC endpoint connectivity between that and the underlying instances upon which the models that you use are deployed. And my colleague Andrew, over the course of this session, will provide you further insight into some of those architectural workflows. Now, finally, it would seem on the surface that customers generally tend to think that models deployed with provisioned capacity are much more secure than models deployed with on-demand capacity, given the fact that on-demand capacity models sit on multi-tenant hosts. I am here to tell you that that is not the case. The level of security, protection, and privacy and segregation and isolation that we provide to models deployed with provisioned capacity is the same that we provide to models deployed with on-demand capacity, and I'll provide you some insight into how we provide those measures. One, for all of the input prompts and the data that you provide to models and the outputs that are generated, the inference outputs that are generated, we do not log any of that data within Amazon Bedrock. Secondly, when you deploy a model, that model, its parameters, and its code remains immutable for the period of inferencing. And the technical significance of that is you're able to mitigate any risk related to things like model poisoning or model tampering. Third, inference hosts are effectively firewalled, and they're firewalled in a manner that prevents them from initiating outbound, any kind of outbound communication. And the technical significance of that is any risk related to data exfiltration, whether intentional or unintentional, you're able to mitigate that. Fourth, all of the inferences that you carry out, from all of the inferences carried out by different customers, are always segregated and sandboxed. So you do not have cases where customer data get mixed up with one another. And then finally, we do not store any data during inference processing. From the prompts that you provide, to the data that you provide to the models, to the inference outputs that you generate, none of that is stored by the Amazon Bedrock service and Amazon Bedrock agents. Now, at this point, I will hand over to my colleague, Dr. Andrew, who will then take you through the data flows for Amazon Bedrock guardrails. Thanks, Andrew.
It's one thing that's worth mentioning on this last slide. The reason we do this, when we have an on-demand model and there's multiple customers talking to the same model, we segregate every single call because we don't trust all of you to play safe together. When you have your own custom model, your own provision model, we don't trust you either. So we segregate and process all your individual team requests in exactly the same way. So we treat those models from the same standpoint in terms of security, because trusting no one from a security point of view is always the right way to go about it. So we'll talk about guardrails first, which seems a bit odd. It's because agents will call guardrails. And so before we can explain how it calls guardrails and what the impact is, we'll show you quickly how guardrails works behind the scenes. We won't talk about the policies themselves. There are lots of things you can define within guardrails, such as how to deny topics, how to block PII, how to block out certain keywords, block hate speech and things like that. And these are all down to you to actually decide and define. We just provide the infrastructure and the way to do it, and it's down to you to define your own responsible AI policy. So what we're going to go through here is just walk through how you create one, how it's stored, how it's then used going forward as part of your application stack. So as before, as Opie says, on the left-hand side, we've got your VPC, we've got private link endpoints, that's coming into the application stack. So we have the data flow accounts again that Opie mentioned, and this allows you to call in from your application. And you'll see above on the private link size on the left, there's a little blue tag that says Bedrock and Bedrock Runtime. Those of you who have ever used Python libraries for this, you know you create a client library by connecting to Bedrock, Bedrock Runtime, or Agents Runtime. And this helps us segregate the APIs behind the scenes, so you can be quite clear that if you have this client defined, you can only call Bedrock, you can only call Agents, and it helps to segregate these things out. But we only have a few of these across the whole application stack. So on the middle section, you will see that we have the content moderation account. This is the piece of our account structure that will actually process the guardrail. It takes your definitions, takes the input prompt, takes an output prompt, and applies the rules to it, and blocks or denies or allows things to go through as those rules say. At the bottom is the guardrails control plane account, and what that does is where it stores the definitions for your guardrails. It's where they're hosted over time, and they get written from there when they're going to be used. So first things first, let's create the guardrail API. And so you call in at the bottom, you go into the control plane account for Bedrock, it patches it to the guardrails control plane account, and it starts to actually process things going forward. Simple, so far. Now, some of the guardrails APIs can be synchronous, so such things like list guardrails. Things like that are really simple, really quick, so they're just synchronous calls. Some are quite long. So create guardrail is one as an example that is asynchronous because there's lots of steps that are going on. You don't want the API call to stay there for like 30 seconds until it comes back to the client. So that is asynchronous. And when you're doing asynchronous things on AWS, what best way to orchestrate them than use step functions? Oh, why not? It works. It's a wonderful service. So we use it internally for all of these things whenever we possibly can. So apply guardrails will kick off a step functions workflow that will then do several things. The first thing we have is a common data access layer that we'll use between step functions and some data storage units. Now, what these data stores do is the first one is metadata. It holds the name of your guardrail, information about where the objects of the policies are stored, the ARNs, just all the information about it, creation dates, versions, things like that. They're all encrypted with AWS KMS keys, and they're service-owned keys because the information in there is not, as we call it, strictly speaking, customer data. It's just metadata about your objects. The important things, your guardrail policies, are stored below in the Amazon S3 bucket, and they'll be using KMS as well. And we recommend you give us your CMKs, your own keys, so we can encrypt it with your keys. This happens a lot in Bedrock. We encrypt everything always, but if you give us your keys, we will use your keys rather than use our keys. And we always say, just please do that because it just makes more sense from an audit point of view that you can tell your auditors that you own the key material for that data store's encryption. It always just sounds better if you could actually say that. It's still KMS, it's just as secure. It's just a case of if you own it, you can rotate it, you can have access to it, and really control how it gets used. So in the policy bucket, we store the information about your denied topics, about your filters and things like that. Now, it would fit in a DynamoDB row, so why don't we put it there? And it's really because in the future, these are likely to go multimodal. We'll start importing images as part of our guardrail policy, or music, or audio, video, whatever. And so we thought from the beginning, if we put it all in S3 now, that's a good thing. And so that's why we split the things up into the Dynamo table just for the basic information about the objects and the objects themselves once they're all stored. So once it's stored, which doesn't take too long really, you make the API call into guardrails. This can come from many different sources. You can call it as part of an inference request. It can be called from agents. You can call it from a specific API just on its own. You may have a situation where you've got a model running quite happily in SageMaker. And so you call the guardrails API to say, check this input. If it works, go to SageMaker, come back, check the output. And so you can actually use it on any system outside of Bedrock to act as the guardrail. When it comes in, the first thing we do is we use the same common data access layer. We then look into the metadata, find out where is your guardrail, what is your guardrail, load all the data back from S3, sweep it up into the top accounts, and we'll begin to actually process your guardrail definitions. Now, these are done in two ways. Some of them, such as word filters and regex, you don't need a large language model to do regex. You can. It's not worth the time, money, or effort, so we don't. We just use traditional techniques or sometimes some basic ML models in there, and we do some of the things there. All the rest, like PI detection, denied topics and things like that, they are specific, highly tuned custom models for that particular task. Each guardrail policy type has its own model, and each one basically runs by itself. And when we do these checks, we do them all in parallel, because there's no point doing them sequential. We may as well do them all at once, and if anything fails, or if anything says block this request, we block the request. This leads to an oddity if you're doing inference streaming, because you will start to see the response coming back. And as soon as we detect one of the content filters or your other policies is triggered, we stop the response of the stream. So it does mean if you're doing streaming responses, you might start seeing some responses before a guardrail is worked out. Oh, the first half of this response was great, the second half is banned, or stop it now. So just be aware if you're doing streaming and guardrails, you might get a partial answer before things get cut. If you're using standard inference that isn't streaming, this doesn't happen because the response comes back correct or it comes back blocked. So agents and the agents data flow. This structurally looks quite similar to the last one. We have the customer VPC on the left with private link. We have the data plan account and control plan account and some models. Now, we don't say for agents here which model we're using because you choose. It's completely down to you. And so it could be Anthropic, could be Amazon, doesn't really matter. You get that choice, you decide. But also in your VPC, you'll see that there's another Amazon S3 bucket called API schemas. And that holds your OpenAI specification for any Lambda functions you want your agent to actually call. Now, you don't have to use Lambda functions. but you will, because it gives most of the power of agents, because it can look things up outside of the LLM, it can look things up in your source systems, external systems, and so you almost certainly will use Lambda functions. And the API schema, encrypt it with your CMKs, please. Don't just use basic KMS, use your own keys. And that will tell the agent in the end, what does this function do? What are its parameters? What's the purpose of it? What can it do? What can it deliver? And as it goes through its chain of thought process and working out how to answer the question from the customer or the user, it can call those Lambda functions because it knows when to do it, because it knows what the Lambda function can do. So those Lambda functions, of course, live in your account. They are your code. We don't allow you to put your code into our accounts on Bedrock. They're always inside your environments. And it's not shown here, but you'll probably certainly drop them inside your VPC as well, so they're running inside that construct. You just didn't make the diagram clear to do it here. And of course, it has an execution role. And following best practices for Lambda, of course, that execution role is minimal. It's doing just what you need to actually do the thing it's meant to do. You don't have open access to everything in that Lambda function. Please don't do that. It's not a good idea. Now, at the bottom, it's just appeared that it talks about an execution role. Now, this we have to give to the agent. The agent has to have a role that it will assume to be able to do things such as read your S3 bucket, access your KMS key to decrypt that bucket, and a few other things that it needs access into environments for. So you have to provide that role. What you don't do is provide anything specific to Lambda functions. What we do there instead is we have a resource policy on all Lambda functions. You basically add the service principal for Bedrock to the one that you're going to allow an agent to call. And so if it's tagged with that resource policy, any agent can call that particular function. And that's really because many of these functions are going to be multi-use in multi-agents. If you have one that can read and update records in Salesforce, you're not going to have 20 versions, you'll have one. Mark it as the Bedrock accessible Lambda function for Salesforce, and then you will call that from your 10, 20, 30 agents that you have defined. And it just makes things simpler and easier. And of course, the Lambda function has its logs. They'll go into your own CloudWatch log group, so you'll see it all, what happens in there. So you'll see when it's being called, when it's being used, and things like that. So that's it, basic configuration before we get started, because the next step is more complex. So you send in the create request into agents, and that has to include information such as where is the API schema, what's the role we want to actually assume, and that will create the basic. Also things like the instructions that you have for the agent to tell it what to do, the system context, prompts, customizations, and they'll come into the agent and it creates the agent. And all that metadata goes into that metadata table encrypted by KMS. You also have to create things called action groups, and they're the things that sort of attach your Lambda functions to your agent as well. So there's a few steps you actually have to go through. You have to then create a version of the agent. You have to then prepare it for use and get it deployed. And at that point, we put a version of it in the agent definition bucket. This is technically, essentially, a pre-compiled version of that agent that we can deploy instantly the second you actually call an agent invocation. So it's there and it's ready to roll. There's nothing to do. It's basically copy it up to the top and just run. At that point, you're going to call the agent. You're going to invoke the agent with your prompt. And the first thing it will then really do is it will go into the control plane account, look up the data you've given it for agent X, load the data up from the metadata store, from the agent definition store, and bring it into the agent runtime environment. At that point, it decides, well, I've got my instructions, I've got my chain of thought process, I've got to call LLMs to try and work out, what do I do next? What's my orchestration plan? What do I do in which order? What 10 things do I need to call? And it will start working out these things slowly but surely. At some point, it will call a Lambda function because that's half the fun of doing agents. And it will reach into there and make that call to, as an example, to Salesforce to look at records. But how does it know who to do it as? Because it's been called by Bedrock agents. It's been called by someone who has the role we've just assumed at the bottom of the screen. It doesn't know it's me. So how can it tell? And actually, out of the box like that, it can't. So what agents allow you to do, when you make the call to invoke agent, you can pass in additional parameters that only go to the Lambda function, such as credentials, tokens, things you need to authenticate that it's me, that you're going to read from Salesforce as me, not as the agent itself. So you can restrict its scope, essentially, by giving it information into the agent runtime when you make that actual call. Sorry, go back one. So when the agent is finished, the results, it passes it back to the user. And it passes back also a session ID to say where this question and answer came from. We'll store that, essentially, first question and answer, in the local session data Dynamo table encrypted with your CMKs, because that allows you to make a follow-up call next with the same question. And so if you get past a session ID back to your client and now make a follow-up question in my chatbot, Let's say I've said list my last 5 orders on Amazon. I get my 5 order IDs with the item. And I say, well, how much was the shoe? How much were the shoes? And you don't have to then do the lookup for anything, because in the session data history store, it will have the answer of the last request, which is, here's your 5 orders. It would infer, oh, the shoes are line number 2. The price was £17, whatever it happens to be. So that to and fro can happen as long as the session is open. You can explicitly close the session, and that kills and deletes the session data information. Of course, most users don't click close or close the web browser. They wander off for an hour and things just eventually time out. So after 24 hours, the session data entry gets wiped anyway. So even if they don't close it explicitly, please write your code so that it does. It's just good practice. It will get deleted quite soon anyway. It doesn't lie around for all that long. A recent change is we now have a long-term session history. So when the session is finished, when it's closed, we'll actually, optionally, if you decide to do it, we can take a summary of what's in session data and put it in the session history and give you a history ID instead. So if I come back tomorrow or next week and say, oh, about my order, what happened to it? Why was it not delivered? And it already has information in the session history. It essentially starts off a new session with that as its initial context. So it knows, why am I here, or what happened last time? And it works quite well. It does open up a potential security issue as well, because that session initially was tied to me. So on your application side, you have to store that history ID safely and securely. So when I log in next, I get it. If you log in next, you don't get it. But at this point, that responsibility is yours, because you've got the access key to the history, not us. So useful feature, very powerful, really can save a lot of time in follow-up interactions with contact centers. But again, the responsibility is yours to treat that key with good secure practices. And again, you can make that session history delete after a certain length of time. It's down to you. So when does it call guardrails? So agent will call guardrails at the start of the process, so when you first put in the prompt and when the final response is coming back. So it doesn't do it in between. You know that with agents, you do the chain of thought. You can do lots and lots of calls to LLMs, lots of lambda functions, and eventually get the answer. It only looks at the prompt and the answer. And each time it will actually call directly into the guardrails account, load up the guardrails, as you can imagine from the screen there, from the policies and the metadata store, and call them in parallel, and return the response. If the response says something, if it says blocked, everything just stops dead. The agent does not make that request, doesn't do the follow-up chain of thought, doesn't do anything useful. If it says mask, such as PI data, allow it in, but mask it on the way out. That's perfectly allowed, and would do that before it goes back to the agent. And so as far as the agent is concerned, it doesn't really get to process much about the final answer. It gets told by guardrails, this is what your answer is. Or actually, you can't give this answer, and everything will stop there. The cross-region inference. This is important in terms of agents, because you can define, you can choose to use a model that's based in the region you're calling, such as, say, Dublin in my case usually, or you can use one that's across multiple regions, across one geo, such as Frankfurt and Paris. And you can do it in the agents, you can do it in guardrails. And so really, you might not think up front you're going to be using cross-region inference, or CRIS as we call it, but actually it's quite likely going forward you will, because not every model is available in every region, as you've probably seen. So how this works, let's take the Central Europe idea, because that's where I live, so hence my diagrams are where I come from. We create things called region sets, or inference profiles, which are based for the EU, the US, or APJ for the Far East. And in that, we have a subset of our regions in that area. So for the EU one, it's Frankfurt, Ireland, and Paris. So let's say you're calling a model, let's say the Haiku 3. That's in all 3 regions. You call Dublin, everything works, everything's great. At some point, let's say there's a capacity issue, a throttling issue, or a service issue, a networking issue. Think these things do happen. What happens now? Well, your call fails. There's no retry. We don't send data to Frankfurt or to Paris, because we don't do that with your data. But if you use CRIS, you can tell us, just don't use the Claude model normally. Use the one that's EU-wide. And try to go to Ireland first, because that's where I've tried. If that works, great. If it doesn't work, try the others that have capacity, and just make sure it happens in that region set or that inference set. And so it might work well in Dublin 10 times in a trot, and maybe the 12th one goes to Paris, just because at that particular time there's a peak of requests from other customers, and there may be some sort of throttling going on. But it means you're the one that's controlling it. You're saying explicitly, I want to use the EU model. If you don't say that, you're using the Dublin model, and you have that complete control. We don't do it without permission in that sense. But there are implications. There always are implications on security for everything that we actually do. So we don't just allow you to do it. If you've got access to a model, we don't give you access to the cross-region one just because. You have to get the IAM profile set up to actually say, yes, you're allowed to call what we call the model gateway, and we're allowed to use the model gateway across these 3 regions, which happens to be the 3 that are in that set. If you don't have that, you can't make the call. It will just be blocked by usual IAM mechanisms. And one thing we get asked all the time, when this was part of the launch, was, yes, I code Dublin. It gets processed in Frankfurt. OK, I understand that. Where are my logs? Are they in Frankfurt? I've got nothing in Frankfurt. I don't want to go and reap logs from a different region. And nothing's actually stored in that region. So the only logs that get stored for cross-region inferencing is also in Dublin. The only change to the CloudTrail log you'll see is an extra field that says, and I was processed in Paris. And that's all you get. There's nothing in that secondary region. There's no footprint whatsoever that anything happened in Frankfurt or Paris. All you see in Dublin is the logs that say, it was here, it was done there, it was done here. And that's the only thing you actually see that's different. So knowing there's nothing persisted in those second regions or the third regions is really useful. There's nothing logged, there's nothing left behind. There's just no footprint left of any kind. But of course, some of you will block regions because that's what customers do. They say we're going to run things just in Dublin and Frankfurt. We're not using Paris just because we don't. And that's their choice. So you may have an SCP set up in organizations that just says block Paris. If you do that, Chris fails, because you're stopping it evaluating where the capacity is at this particular point in time. So it just will not work. You can't say, I want to use an EU set, but not Paris. It just does not work. So what you have to do in your policies of SCP, you have to go in and basically say, deny everything for Paris, except the cross-region call for Claude Haiku 3. We'll keep that. Everything else, we're not doing anything. So you can't launch EC2s. You can't launch sort of Fargate clusters. None of this will actually work. All you're saying is, I'm going to allow cross-region inference because I know nothing gets stored. I trust that nothing gets stored. It's just used for that LLM request and nothing else. So how does it work? It's actually quite straightforward. So you look at the inference request that Opie showed earlier, that you have your VPC on the left. You make the request, let's just say to Dublin, or region 1 on the slide. We try to decide, well, where is this model? We find a cluster for on-demand compute for Haiku 3. There it is. And we'll make that request. However, something's going to go wrong sometime eventually. It may be the model is out of capacity. It may be you've called a model that isn't in Dublin. It may be there's a networking issue or there's some other constraint that's caused that call to fail. So what we'll do is, rather than failing, we will look for another region in that set, so Paris or Frankfurt, and decide where is my capacity right now? Where can I call now to basically solve this particular request? And so we find that region. It could be any of the two. And we make that request across the AWS backbone, which is quite important because once it's on the backbone, as we've said for years in our documentation and networking presentations, once it's on there, it does not come off. There is no way for an IP owned by Amazon piece of traffic to go to an IP owned by Amazon location to leave the network, because there is no route that actually makes any sense anyway, and we have policies in place that stop such things actually leaking off the network. So once it's on, it's on. This is the same thing as well for things like cross-region traffic anyway, between regions, that once it hits the backbone, it stays on the backbone, and that's always going to be the case. And it also takes advantage of things like on the network. You do the things like hardware encryption as well as everything else on inter-region connectivity. So that's there as well to add extra things to it. But once it's actually there over the trusted network paths that we have, it will just find the second region. Let's call it Paris. And it'll go straight to the runtime inference. It doesn't re-authenticate because it doesn't have to. So it doesn't go through the API. It goes direct. Because we already know who you are. You authenticate on the left-hand side for Dublin. It's still you. There's no change. So that percolates across to the runtime inference in Paris. We find the Haiku model, we make the inference request, and then it comes back to the caller in Dublin. As far as you're concerned, nothing odd has happened except the latency is slightly higher from calling, say, Paris from Dublin if you happen to be in Northern Ireland. But other than that, it's exactly the same, plus that extra CloudTrail entry that says, by the way, we were processed somewhere else. And that's how cross-region works. There's nothing to set up as such. All you have to do is enable the IAM you need to be able to call those models and decide to call them. And everything else will just work automatically. There's nothing you actually have to do to make it work. There's no failovers you have to take care of. You're not looking for failure codes. You're not looking to retry anything. It would just find a model somewhere, in that case in Frankfurt, Dublin, or Paris, that will do the work you actually want. Okay. The last slide. So when we first began doing sort of GenAI 2 years ago, we used to do a lot of presentations around the threats that are going to come and get you. And it was like 7 or 8 high-level threats. that were just really there to open people's eyes to things that will happen to you, that will come for you, whether you like it or not. And we're talking about things like reputational risk, when you have the chatbots that go mad, that turn racist, start spouting hate speech, which does happen in the news quite a lot. Perhaps you're leaking IP. Perhaps your actual core central systems that are using RAG are accidentally leaking information that's confidential to your company, in which case that's a bad thing. So there were 7 or 8 of these at that time, and this has now unfortunately grown quite a lot bigger. So one thing I like to look at, and we'll talk about this a lot more at reInvent, our customer conference in December in Las Vegas. There's more sessions on these things then. One thing is the Maestro threat model. So this is the multi-agent environment security, threat, risk, and outcome model. It's designed to really look at what can happen to an agentic system, look at the various aspects of it from different layers, 7 layers in this case, of where things can go wrong, where things can be attacked, how things can be broken up or broken into. Each of those has a number of threats. So the layer 7, which we'll talk about briefly, has got 13, just the top 9 here that piqued my interest anyway. So these are the ones that you really should be looking at more. But there's an awful lot of these. They've got a lot of write-ups between each one of how it applies to you, how it applies to your environment. How it applies to your environment, unfortunately, is a bit of an eye chart diagram of a standard application. You're at the top. Below that is your agent that you're calling. Next to that is your large language model that you're calling. At the bottom is things like long-term memory and vector data stores, things that are supporting your agent in the first place. So if you're doing RAG, you need the vector database, has to be there. On the left-hand side, you've got services, so your databases, other code devices, looking things up from the internet, other third-party services, all great. And human in the loop, which gets its own special number on this diagram. And on the far right, you've got agent number 2, agent number 3, because you've got a cascading agent system, hierarchy of agents, operation of agents, lots of variations of the theme, but we just say there's more agents on the side. Only the first agent is actually visible to the application. And that's where sometimes part of the problem comes in. So one of the good threats, I like T10, because one thing we always talk about to customers is if you're doing a mutating change in GenAI, having a human in the loop is probably a good idea in case that file gets open accidentally. You drop the main database tables. You do something really insane because GenAI hasn't quite given you the right answer. LLM's not quite behaving properly. So give it to a human. The problem with that, a good threat attack for this is sort of cascading overwhelming the human in the loop. If you on purpose keep doing things as an attacker to actually make and force a human in the loop request, the humans will go overwhelmed and you will run out of people. And what that will do is block out the main systems that you have, because your agent is still in memory, it's still running, it's still taking up resources. So if you do a few thousand of these back-to-back requests, the human side of it just fails. And so something could go wrong on that side of the system. Perhaps their own systems overload, perhaps your queuing system gets overloaded. And what you have to look into thinking is, there's humans in the loop for everything. Is that the right thing? Probably not. Maybe there's some low-risk things you can do automatically. Maybe you are updating an RFID tag to a different user. That might be allowed. Maybe you're opening a firewall port. That's not, that needs a human. Maybe you're closing one. Yes, that could make my application break, but it's not a security issue, so that will let that one go through. And so you make a decision based on your own risk scheme of which ones do we actually have to have a human involved in and which ones do we not. T5 is a good one. It's just above the model, the black model in the middle. This one is cascading hallucination attacks, which is going to add more issues with you in terms of reputational risk, I guess. Because hallucinations are a thing, we can't escape them, they're always going to happen, no matter how much we try, there's always going to be some in existence. So if you get a model, the first one returns a response to the agent that's not quite correct, okay, it's not great. But if that then sends that request to agent number 2, the context for agent number 2 contains incorrect information to start with. So whatever it's trying to do, whichever it's trying to orchestrate, is based on incorrect data, it's not true, and it's going to give you an even worse answer. And when it comes back to the application, the output could just be bizarre. And so you have to look at that and decide, well, what can we actually do? Do we do lots more source validation of the places where data is coming from? Do we do a lot of work on the RAG system, on the RAG data entries to make sure these are actually correct? Do we make sure we don't have old versions of things lying in there that are out of date? And you can also do things as well, is do things like using guardrails for automated reasoning or ground truth to basically take the output from the agent 1 and think, is this correct? Can I mathematically prove that this output matches the input and matches the data that we have behind the scenes? If yes, great, pass it on to agent 2. If not, you're relying on agent 1 getting it correct, and that's not always the case. So there are quite a few of these. Don't take a picture of these. You can find them all online if you look at Maestro. But simple one-liner, resource overload is a good one. You can always take out CPUs and GPUs. It's easy to do. Poison the long-term memory store. That's always a fun one. If you can inject things into the memory store, you can impact the next user. And there's quite a lot of these. Yeah, agent communication poisoning. If you're going from agent 1 to agent 2, how is that communication handled? So it's going to be a request from one system to another, one resource to another one. But who controls that? Sometimes these things are not put together that well. Talking of things that may have security issues, MCP. MCP is actually really good, really powerful, really strong. The most recent iterations have more security things in it, which is a great thing. It's just going to get better. But what you can do with Maestro is you can overlay a lot of the Maestro things onto the sort of the main pillars that are relevant to MCP security. And so you may have your list of things you have to do for MCP, which is all good. But having this layered approach with Maestro as well does mean you can identify and categorize threats quite easily across all these different areas. And so we like Maestro. It's not really an AWS recommendation as such, but as security engineers, we quite like it. It's a good thing to look at and good thing to play with. And we always recommend you have some kind of framework along these lines. I mean, for years, we've all been using things like NIST. ISO 42001 is another one you're starting to use. This is another. And I think if you're serious about agent security, you have to adopt something like this, whether it's theirs, whether it's OWASP, doesn't really matter. It has to be something that gives you a plan of attack on how to mitigate against all of these things. And again, another slide, this is roughly where they all fit in. But this is really the end of the Maestro slide. So if I just pass it back to Opie to finish us off.
Thank you, Andrew, for that. I hope the session has been quite insightful. There's a QR code on screen that you can actually access that takes you to the site for builders and the AWS community. And sorry, does anyone want to take? Okay, I'll give a few seconds for you to do that to get started for free. Are we all good? Okay. And then finally, for greater insight into some of the items that we've covered today and others that we didn't cover, because, for example, things around fine-tuning, continued retraining, and even delving deep into the Amazon Bedrock, agents framework, security practices that are available within that, you can actually, go to our Skill Builders platform, create an account there, and a wealth of training courses that would give you greater insight into some of the things that we've mentioned here. I want to say thank you for taking out the time to listen in on this session, and I hope it has been helpful to you all. There are other security-based sessions that we would have after this, actually, and I encourage you to actually attend those sessions. Thank you for your time, and have a wonderful rest of the summit.